There are different ways to represent functions, and functions were the topic of the previous video, so let's talk about representing them. There are a few ways to do this, and this is what we'll cover in this particular video. We will talk about the graphs, about using graphs to represent a function. We'll talk about representing them with a table of values. And then we'll talk about scatter plots. And then we'll mention the vertical line test. So these are all different ways we can represent a function. And keep in mind that as long as we're in calculus, primarily we're going to be focused on talking about f of x equals some sort of rule. I'm going to return to the one we've already put up on in the screens before, x squared minus 1. So how do we want to represent this graph? Well, one way to represent the graph, or represent the function. So how do we want to represent the function? The first way we can do this is to represent it using a graph. And I think we've all seen this kind of thing before. You have a graph. So you have your x-axis. And the vertical axis is oftentimes labeled y. So this would be your y-axis. But keep in mind the y-axis is the f of x axis. That's where the f of x part gets graphed. We've always got to make our little tick marks along the way. I'm just going to say this number up here is 10. I hope that we are all familiar enough with this that this will be -1, -2, -3. So we want to represent this graph. What we would do is we would simply locate the vertex, and then we would start drawing the parabola as it would be drawn. By the way, this is a horrible representation of this graph. I can try to do a better job, but my artistic skills are somewhat challenged. I believe they are very generously referred to as developing. All right, so there's a graph of x, or that's a graph of the function f of x. What we need to realize is that each point on the graph is a domain, range point. So right here, let's say that our x value is 2. Well, the range point that goes with 2 is 3. The 3 is f of 2. Remember, f of 2 would then be 2 squared minus 1, which is 3. So that's something else we can say about this. These points on the graph, you could say this is actually 2, f of 2. So we do have this kind of relationship going on here, and these are the graphs. So each point on the graph is a domain point, its range point. That's just what graphs are. They represent the collection of all domain range points, if you think about extending that infinitely far. So that talks about working with graphs. We can also work with tables of values. So we talk about tables of values. All we do then is we make a table where one column is x and the other column is f of x. So we put down some candidate x values. Then we put down their function values. If you plug -3 into f of x, so just as a demo of what goes here and here, we'd say f of negative 3 is negative 3 squared minus 1. Well, that's 9 minus 1 is 8. And so an 8 would go there because that's the function's value when x is negative 3. Similarly, you can go through this and find that this is 3, f of negative 1 is 0, f of 0 is negative 1, f of 1 is also 0, and f of 2 is 3. And so that's a table of values. Oftentimes we create a table of values before we plot a graph to kind of have an idea of what that graph might look like. So plotting points tends to help us figure out what the graph would look like, and the graph helps us understand things. So table of values is exactly that. It's just a list of some selected x values along with the calculated f of x values. So it would be a table of values. Which brings us to something called a scatter plot. So exactly what is going on with scatter plots? All right, so let's go to a new sheet here. All right, so we want to talk about what a scatter plot is. What exactly is a scatter plot? Sometimes you are provided a table of values without actually knowing the function. And sometimes you're presented a table of data values that are measured when you're doing an experiment or when you're doing some sort of research. And so with a scatter plot, what you'll have is you'll have a collection of ordered pairs. And so you have some values you might label x, and you'll have some values you might label f of x. Alternately, you might have labeled those y. And so perhaps your x value is negative 3, and next to that, perhaps the value is 4. Maybe another x value you have is a 4 with an f of x equal to negative 7. Maybe you have the x value 0 with the y value of 5. And perhaps you have the x value positive 3, where the y value is negative 2. Now, I don't know a function off the top of my head that has those points on it, but the idea is you're given points. You're given a table of values where you have x values and y values, and these are ordered pairs where order matters. The scatter plot is just plotting those points, which most people have been doing since, I think, 3rd or 4th grade. I remember my kids doing it very early in their careers. And so the point negative 3, 4 might be right about there. Positive 4, negative 7 might be down around here. 0, 5 would be up here. And 3, negative 2 would be down around here. I can actually imagine a cubic that goes through these. That's all a scatter plot is. It's plotting the points that you're provided. As a side note, this often happens when you're working with statistics or working with data from an experiment. So for instance, if you wanted to put this into an example, perhaps you had height and weight of 5 men. And so you'd have height in one column, and you'd have weight in another column. Perhaps one gentleman is 73 inches tall and goes 195 pounds. Perhaps another gentleman goes at 68 inches tall at 115 pounds. Maybe another one goes at 71 inches and weighs in at 172 pounds. We have another one that is 74 inches and comes in at 250. And your fifth person, let's say, is 70 inches tall, and they come in at 195 or 190. So this would be a data set, and you would simply then plot those points. So this is just a situation that you might have. A situation you might have is that you have data pairs that you wish to plot. And again, when you have data pairs, how will you know if it's a function or not? What you need to realize is if you've got data pairs, it's only a function if no x value is related to more than one y value. Remember the definition of function, each x value is related to exactly one y value. So what you can't have, so if we were to actually amend that table, what we couldn't have here is a 73 coupled with another, let's say a 158. You couldn't have that. Now it's not a function. It's not a function because now you've got the same x value mapped to two separate y values. So when you have a table of values, be aware it can only be a function if no x value, if no first column value gets assigned to two different y values. And that's something we need to keep in mind. All right, the same kind of idea can manifest instead of being in a table and using a scatter plot. You could also be given a list of ordered pairs. For instance, you might be given 2, 6, 3, 8, and 5, 36. Now these ordered pairs, if you wanted to then make a scatter plot out of them, you could. And those ordered pairs would, as they stand, be a function. Because notice that each value is related to only one. Each first value, each x value is related to only one y value. Each domain value is related to exactly one range value. So right there, that's a function. It fits the definition. Each domain value gets associated with exactly one range value. However, if you want to know what not a function looks like, we could have the ordered pairs, let's say 2, 6, 3, 8, 5, 36, 6, 10, and 3, 15. Notice this is not a function. It's not a function because the domain value 3 is associated with the 8, and the domain value 3 is also associated with the range value 15. So this list of ordered pairs is not a function. All right, now remember, really the point that we wanted to make here is that you can represent a graph with or represent a function with a graph. We already saw that. You can represent a function with a list of ordered pairs. We saw that you could graph those ordered pairs. And then we talked a little bit about what would make it not a function. And remember, the only thing that breaks it, the only thing that's going to break these table of values or these graphs or these lists of ordered pairs, the only thing that's going to break those is if you have a domain value that is associated with two separate range values. Right, so we can represent it with a graph, which we've seen. We can represent it with a table of values, which we see right here. We can represent it with ordered pairs. And we're also now aware that if you have two domain items, or if you have one domain item sent to two different things, you have one domain item sent to two different things is no longer a function. So let's take a look at what that means for the graphs of functions. Right, so for the graph of a function, remember, I'll go ahead and undo that. Remember that for a graph of a function, we have the x values here. So this is the domain. The domain values are on the horizontal axis. And as far as we're concerned in this calculus class, that domain is almost always going to be x. We also have the range values located vertically, which for us is going to be primarily f of x. So what would a function look like? A function might look like this. Okay, notice that each domain item gets mapped to exactly one range item. There's no place here where it's possible for domain values to go to two different range values. However, if I draw the graph like this, notice here that this value, this domain value, has that range value, and this range value, if I could draw vertically. So right away we see this can't be a function because there's a domain value that gets associated with 1, 2, 3 different range values. And that causes a problem. So that's how we know it's not a function. And this actually is where the whole idea of the vertical line test comes from. A graph is the graph of a function if all vertical lines pass through at most one point. Pass through at most one point. The reason why I say at most and not exactly one point is I think you can imagine the following function. Notice here, there's some vertical lines that don't hit it. So it's okay if a vertical line misses the graph. The thing is that when it hits the graph, it hits it in exactly one spot. Sometimes we turn this around and we say what's not a function. So the graph is not a function. Is not a function if a vertical line passes through, I should say if any vertical line passes through more than one point of the graph. So a graph is not a function if any vertical line passes through more than one point. So if you've got any vertical line that can pass through more than one point, not a function. As a matter of fact, we can come back over here and we can take this, and if I just put one extra point right there, notice that now we have a vertical line that hits the graph in two places. So a graph is the graph of a function if all vertical lines pass through at most one point. The flip side of that, the way we say something isn't a function, say a graph is not a function if any vertical line passes through more than one point in the graph. That's how we'll be able to identify those things. All right, so there are some preliminaries on functions. The next video that we'll have will be about special kinds of functions and categorizing those functions. And again, this is part of the review material.